Okay, so I've added a new topic that's not on the course outline, and the topic is limits because it's important for understanding calculus and different concepts. So first we're going to learn to evaluate them using algebra and other limit properties, which I'll show on the next slide. And then we will learn to evaluating limits using this ruler right here. And also I just want to note that if a slide has a lightning bolt on it, that means it's just a new topic that's not on the original course outline that I had shown you guys. Okay, so limits. Limit of a function. So we're first going to look at limits for that are approaching a constant. So for example, if you have something like the limit as x approaches 2, something like that, we will not be looking at least not right this second, limits that approach infinity or negative infinity. So we're just going to be looking at these right now, but then in a second or two we'll be looking at those. So here are some properties. If b is a constant, then the limit as x approaches c of b times a function, you basically pull the b out of the limit and then just evaluate the function itself, because b is just a constant, so you would just multiply it by the limit of that. Here's the next one. If we have two functions being added together, you can separate them and take the limits individually. And if it's subtraction, you can always do the same. So you could just do, so say we had a function that was 2x minus 5x, and we wanted to find the limit of that as x approaches, say 2, it doesn't matter. What you can do is you can take the limit as x approaches 2, and that's a constant, so you can pull that out in front of x. And then since that's a minus, you could put a plus and then pull the constant out, 5. Well, that gets a little complicated actually. So that's not a very good example. Let's pretend that's not there. So pretend it's just minus x. You could do, let me just erase that. You could do then plus the limit of as x approaches 2 of negative x. So you don't have to worry about that being a negative and that being a positive, and you can just change that to a positive and have that as a negative. So that's just an example. We'll see more better examples in the next couple of slides. And then if we have two functions being multiplied together, you can take the limit of each individual one and then multiply the limits together. And then just three more properties. It's pretty similar to, this one's pretty similar to the one I just showed, except if you're dividing, you can take the individual limits and divide them by each other. But that's provided that the limit of g of x, so the one in the denominator, is not equal to 0, because then you would be dealing with undefined and all that stuff. And then if you're taking a limit of just a constant, it's just simply the constant. So if you're taking the limit as x approaches 3 of 5, the answer to that is just 5. Because it's always approaching 5, it's always at 5. And then if you're taking the limit of x, if you're taking the limit as x approaches c of x, it is just c. Okay, so here's our first example. So what we want to do is use the properties shown on the previous two slides to solve this. Well, actually, before you even do that, it's a wise idea to check to see if you can just plug this directly in, because the properties shown previously are mainly used if you get something like 0 over 0, or some number over 0, because that's undefined, so we want to avoid that. But first we should just check to see if we can plug it in, because it looks like we will be able to, because it's a 3. And so like, if we had like 5x squared plus 2 divided by x minus 3, and we just plug the 3 in, we'd get a 0 on the denominator, and that's what we want to avoid. But in this case, it looks like we will be able to just plug it right in. So let me, so we just plug it in, so 5 times 3 squared minus 8 times 3 minus 13 divided by 3 squared minus 5. So 3 squared is 9, 9 minus 5 is 4, and then 3 squared is 9, 9 times 5 is 45, minus 8 times 3, which is 24, minus 13, that is equal to 45 minus 24 minus 13, that's equal to 8 over 4, which is just 2. So the limit of this function right here as x approaches 3 is 2. Now here's an example of what I was saying previously with just plugging it in and getting a denominator of 0. If you just plug in 2, so I'll write this in red because this is not what you want to do. If you plugged in 2, you'd get 3 times 2 squared minus 2 minus 10 divided by 2 squared minus 4. So you don't even have to do the stuff in the numerator. You know off the bat you'd get 4 minus 4, which is equal to 0. Now that would make it undefined. So we need to use properties to make it so that we can evaluate the limit. So I think a good place to start off would be using the property that involved division and splitting it up. So we can do the limit as x approaches 2 of the numerator, which I'll write in a second, divided by the limit as x approaches 2 of the denominator. So x squared minus 4, 3x squared minus x minus 10. And we can even split it up further by, I'll write it down here because I'm running out of room kind of there. The limit as x approaches 2 of this term here, 3x squared, and then remember what I said, you can change that to a plus and then just make that a minus. So we'll do plus the limit as x approaches 2 of negative x. And then if you remember, for a constant, the limit of a constant is just a constant. So then we can just put subtract 10 because that is the limit of minus 10. And then do the same for the numerator down here. Limit as x approaches 2 of x squared. And then minus 4 is just minus 4. So I'll put that in parentheses. So now what we can do is find the limit of these. So for this term right here, we can pull out a 3 if you remember, using another property, so that gets rid of that. And we could take the negative out, but we'll just leave that. So what we want to do is look at what the limit of this is right here. So if you plug in a 2, you get 4. If you plug in a 2 here, you get negative 2. And then just a minus 10. Now here we still have a problem because it is still plugging in a 2 and getting a 4, and it would just be a 4 minus 4. So I'm going to try to go back and erase this out of this video because I just realized that I was doing a ton of work that wasn't necessary because I was thinking that this was cubed, not squared. So if I don't get that erased out of the video, ignore this problem up until now. So just ignore everything in this problem up until now. But the mistake I made is I thought that was a cube, so I was thinking we had to go through all these steps. But if that was a cube, we wouldn't have even had to go through those steps. So it was just a mistake on my part. But what we can do with this, since these are both quadratics, we can factor them. So we have a 3x, an x, that'd be a 2, that'd be a 5, so that's 3x, 6, so that'd be minus, that'd be a plus, minus 6 plus 1, yeah. So you factor the top into that, and then this is a perfect square right here. So what we do is we have, or I don't know if that's the right word, perfect square, I don't know. But since there's nothing there, it's a plus and a minus. So then what we can do is cancel these, and we get 3x plus 5 over x plus 2. And we still can't just plug this in because that would still get us 0 on the denominator. But now we can start doing those steps that I was doing previously. So we can take the top, divided by the bottom. And then we can separate them further. But if you remember, constants are just constants, so then we can just kind of do that. And then we can pull the 3 out here. So the limit of this is, so now let's go down here. The limit of x as 2, or x approaches 2 is, you just plug in 2 and you get a 2. But remember, we're multiplying it by 3. And then you add the 5, so that equals 11. But you're dividing by that, so you plug in the 2, which is 2 plus 2, so that's 4. So the limit of this is 11 over 4. If that confused you because I did it wrong originally, then just post a comment and let me know if you want me to do another problem or not. But I'm sorry about the mix-up. I just was thinking that I couldn't just factor it. I was making it more complicated for myself. But that's the correct way to do this. So in the next video we will be doing limits as x approaches infinity and negative infinity.